All right, now that we've done ratios themselves, there's a lot of different uses that you can have, so we're going to do one that's a little bit more unconventional, something that we kind of take for granted, but we don't really notice. It's a very simple concept that ratios can be used for. So, before we start that, let's just get a picture of it, and that's what we're going to do with number 1. It says, below is a diagram of a candy bar that is being shared between 2 people. The bar will be shared with a 3:4 ratio of part A to part B. So what that means is part A will get 3 pieces for every 4 pieces part B gets. That's a 3:4 ratio. So how many total pieces do we need to cut this into? Exactly, 7 pieces. So we need to cut this into 7 pieces. Let's see if I can do this fairly nicely. That's 6 slices. That's not really nice, but 1, 2, 3, 4, 5, 6, 7. We're going to assume they are all the same. That's A. He gets 3, and B is going to get 4. And this now picture tells us everything about it, which will now allow us to answer the following questions. So let's see. It says, what fraction of the bar will A receive? Well, A is going to get 3 out of 7. So just from that little ratio of 3:4, we now know that A gets 3/7. Part B is how much of the bar? Well, it's 4 out of 7, so 4/7. And then now times. This is the clean thing. Part A is blank times as large as part B. Well, you can use the ratio itself. Part A gets 3, part B gets 4, so that means part A is 3/4 times as large as part B. Nice little use of a ratio. So it's not just a ratio of 3:4, it's actually how many times larger A is than B or B is than A. So part B is 4/3 times as large as part A, because B is 4, A is 3. Isn't that kind of cool? If you don't trust me, let's look at it. A is 3/4 times B. How many pieces does B have? 4. And if you cancel it, you get 3. Part A gets 3. That's it. So if you know the ratio, you know how many times larger one is than the other. So if they say it's a 2:1 ratio, you know that one is twice as large as the other. If they say it's a 5:3 ratio, you know one is 5/3 times as big as the other. Or the other one is 3/5. You just reciprocal it. See? Okay. Here's one for you to try. Actually, I got extra down here for you to try. Let's do one more together, just to show you some nice stuff about it. So 2 landscapers mowed the lawn of a wealthy family. When they finished, landscaper A mowed only 3/7 as much as the more experienced landscaper B mowed. Well, since this is 3/7 times, we already know that that 3 and that 7 belong to someone. Remember, that ratio is the same as the multiple. So that means the multiple is the same as the ratio. So that means they have a 3:7 ratio, because A has mowed only 3/7 as much as landscaper B, meaning that A is 3/7 of B. So that means A mowed 3 portions to B's 7. So if you were to draw a picture, you need to cut this into, you guessed it, 10 pieces. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And A, you're going to put 3, and B, you're going to put 7 of them. And that's nice. See, so if you know the multiple of one to the other, you also know their ratio. And if you know their ratio, you know their multiple. So what is the ratio of A's part to B's part? It's 3:7. And then part B was supposed to say something else like that. What is the ratio of B's part to A's part? It's 7:3. It's just the reciprocal, because whatever comes first, that goes on top. Whatever comes second goes on the bottom. And that's it. Alright. A's part is what part of the lawn? Now this is talking about a fraction. We're not talking about a ratio of A to B or how many times A is to B. It's A's part. How many are for A? 3. Is what part of the lawn? How many pieces total for the lawn? 10. So that's where we get our fraction of 3:10. It's very important to pay key attention to the wording, because that tells you everything. If you're dealing with A and B, you're dealing with a ratio of A to B. If you're dealing with A in the entire lawn, you're talking about a fraction of the lawn. B was not mentioned. You do not use B. Okay. So A's part is, well, A is 3. Blank times as much as B's part. B's part is 7. So that's a 3/7 times. And if you check it, multiply by 7, you get 3. Okay, so here's the nice application of it. Because what if this is your friend? You guys had just done this lawn, and you were B. He's A, and he got kind of slackish and didn't really do that much. And you've worked your butt off, and you did much more of the lawn. Well, you want to be paid an equivalent rate, right? So you said, look, I did 3/7 times as much as you. So think about it. If they were paid $150 for mowing the lawn, what would be a fair split of the 150? Well, you would use the ratio, right? How many total pieces are there? There's 10 pieces. So that means if you take 150, divide it by 10, you should get $15 per piece. Well, using the ratio, which is 3/7, we know that each person should get paid accordingly. So 3 times 15 is 45. This is A to B. And 7 times 15 is what? That's 90, 105? Obviously, 150 minus 45 is 105. So that means A would get $45, and B would get 105. And if you don't like this, you could use the picture. So if you look at it, there are 10 pieces because it's a 3/7 ratio. So if you take the 115 and divide it by 10, you get $15 per piece. And then where you can see that there's 45 for A and 105 for B, whatever's left. And that's it. So one little multiplication, and look at all the info we get from it. We know the fraction. We know how many times larger one is than the other. We know the ratio of A to B. We know the portion of payment, just off of one little ratio. It's a nice little application. Let me have you try this one. Try number 3. So Pat and Ron split a cake. Pat's share is 2/3 as large as Ron's share. See if you can answer all these questions from it. And then if you feel like you got it, try the application problem of number 4. Alright, that's the life question right there. Tim worked 30 hours last week. Okay, so try number 3. Hit pause and give it a shot. Alright, so you should have gotten these answers. So if we have a Pat's share is 2/3 times as large as Ron's share, or 2/3 as large as Ron's share, that we know Pat is 2, Ron is 3. So Pat gets 2 to Ron's 3 for a total of 5 pieces of cake is what you'd have to cut it into. Alright, and then we can answer it. What is the ratio of Pat? Well, Pat gets 2 to Ron's part. Ron gets 3, so it's 2/3. What fraction of the cake? Well, the cake is made up of 5 pieces. Pat got 2, so it's 2/5. Ron's share is 3. Pat's share is 2, so Ron's share is 3/2 times as large as Pat's share, or 1.5 times. And then what is the ratio of Ron's share, where Ron is 3, to Pat's share, which is 2, 3/2. And that's it. Alright, let's see if you can answer this one correct. We're going to do it together. Tim worked 30 hours last week, which was 5/3 times as many hours as Robert. So we know that Robert did 3 to Tim's 5. Okay? And Tim worked 30 hours. So if we do a 5-to-3 ratio, and this is Tim to Robert, then we know that Robert did 30 and Tim did, well, we don't know. And you can do an equivalent fraction, which gives us 18. So Robert did 18 hours. Or you could reverse it. We know that Tim did 5/3, so that means Robert did 3/5 of what Tim did. So 3/5 of 30 would be 90 over 5, or you can reduce it and put 18 hours. They all work. You can either use the ratios and treat it as an equivalent fraction, or you can just think about it and say, well, if Tim did 5/3 of Robert, Robert did 3/5 times Tim's. And then you can just multiply it. And that's it. Thank you.